Okay, so let's start. Good afternoon, everyone, and welcome to today's webinar on power-constrained IoT projects using our LoRaWAN module. We will leave some time to answer your questions, so feel free to type them in the Q&A box during the presentation, and then we will read them in the end. So, before we dive into the content that we have prepared, I would like to introduce myself. My name is Ilania Carola. I'm in charge of the business development at Move-X. And today we have a special guest joining us who will bring a rich expertise in the IoT solutions. So it's my pleasure to introduce Alexander Cartwright, the product development engineer at VER FACIL. So thank you so much for joining us and for agreeing to share your application with our modules. So, what does Move-X do? So Move-X develops a low-power, high-performance processing unit for the electronic global market. We have a big expertise in high-quality end-to-end support, the development of product ideas and industrial embedded system. We are also specialized in the LoRaWAN-based solutions for power-constrained IoT projects. And our products are applied in a wide range of industries, such as smart cities, smart agriculture, and so on. Today, we are excited to have as a guest VER FACIL. VER FACIL has implemented our LoRaWAN module to upgrading some design, often based on the Relay and PLC, adding to them some IoT functionality. Alex will show the implementation of our LoRaWAN module in projects such as pump controller, underground plant room, air handling unit controller, IoT retrofit for building management system, and also for mining vehicles. But first, let me give a brief introduction on the MAMWLE, the LoRaWAN module that has been used in all these projects. So our LoRaWAN module has been designed to reduce your BOM, optimizing the supply chain and also the certification time. Is based on the STM32 WLE5 system on chip. It's really small. It's just 1.5 centimeters for 1.5 centimeters. And also it has a super powerful core. It comes in two versions. The first one is the bigger one, 256 of flash. And also we have a smaller version that is 128 flash. Also, one characteristic of our LoRaWAN module is a large number of peripherals. We have a big number of GPIO. This means that our LoRaWAN module it's really it has a big versatility. Also, this is really important. It's something that you can hardly find in the other LoRaWAN modules, is that you can use just one module for all the bands that goes from 868 till 915. So you don't have to stock for each market you will be operating in, but you can just stock our module and then program it to be used in all the bands in that range. Also, it comes with two different antenna plug. There is the UFL connection in one version, in the other one the PAD connector. This means that you can easily design your RF design. Also, we give a full documentation to program it, and also you can program it in the STM32 IDE, the ecosystem from ST, or in the Arduino IDE. It's all on our GitHub page, and we are more than happy to guide you through the documentation. So let's go on. And so how the LoRaWAN protocol works. The LoRaWAN devices use what is called a star network topology, which means that they communicate directly with a gateway or a base station, and the gateway acts as a bridge between the devices and the LoRaWAN network server, allowing the data to transmit to be transmitted from the devices to the cloud for analysis and processing. But why using LoRa? Why using LoRa? Using LoRa has many advantages. We are trying to list some of them. So the long range, in fact, all the devices programmed on the LoRaWAN protocol can communicate up to several kilometers. Of course, the low power. So those devices can be can last up to years, several years. Also, it's resistant to interference. It's a protocol more reliable than the communication through Wi-Fi and Bluetooth. And also, it's a license-free radio communication. So you do not need to subscribe or to pay extra fee. Last advantages of the one that I want to list is the low cost for all the reasons that we already said. So let's go on. I would like to leave the floor to Alex, who will go into details of how our LoRaWAN module can be used in real life applications. So Alex, if you want to share your screen, I will leave.
1 second. Afternoon, everyone.
Yeah. Thank you so much again for joining and for presenting.
Everyone see that okay?
I see.
Yeah. So thank you very much for a very nice introduction. Like Jeleni has just said, we're going to have a look through some of the applications that we've used the MAMWLE device for and show how IoT has really sort of benefited the applications that we've used it for. So yeah, I work for VER FACIL. I'm the product development engineer. Now, I was going to take you on a sort of a little run through of what we've done previously so you get an idea of what we're looking at. We've got a history of working with building management systems. So we're talking boiler controllers, air handling units, that kind of stuff, you know, big equipment. There's a lot of water and pipe monitoring with that as well. So we're talking things like leak detection, pump controllers, and from that we started to move into places where you can use a lot of that technology as well. So agriculture, highways. And as part of that, we actually have started to roll out LoRaWAN gateways across Cornwall as well, because the more sensors we wanted to deploy, the more we realized that it would be really good if we could provide the rest of the infrastructure as well. So we now have LoRaWAN gateways installed, which give coverage for just a huge amount of Cornwall. So what we're going to be talking about today is not just how we've found applications in those sectors, it's how we've actually designed products for those applications. So it's a look behind the scenes, let's say. There's a few little pictures to give you an example of projects we've done there. You can see the two on the left-hand side, that's for river height monitoring, so for sort of flood risk, flood detection. The one on the right was a wildlife monitoring program in the Isles of Scilly. That was a really good use case for LoRaWAN, again, because of its long range. So, and what are pretty remote islands, there's limited coverage of other networks, whereas the one LoRaWAN gateway nice and high up, you can see across all the different islands there. And that's an example of some of the gateways just below of the ones that we've rolled out across Cornwall. So a bit more about what we do in-house. We've got quite a few different products that you'll see in a minute where companies have come to us with a specific idea. They need a solution for it, and rather than putting together a load of different bits and bobs and having to outsource different bits, we've taken the whole design process in-house. So everything from schematic capture and actually choosing the layout of the circuit board, the PCB, then programming the microcontroller, and then doing all the analysis afterwards, so power analysis and function monitoring, and then even the hardware section of it as well. We do all of that in-house so that we can go from nothing to complete solution, all whilst talking to our client to make sure that we've got something that's really useful for them. And the reason that we're talking about it today is that the MAMWLE device has become a really big part of pretty much all of our solutions, which you'll see in a moment. So like Eleni was just saying, one of the main advantages to us is that the bill of materials becomes so much more simplified for the microcontroller. Instead of having to worry about the controller, the crystal, then putting the radio on, we know that every time we can put the MAMWLE device on and it just works, that we are good to go. And that really, really helps us get products out the door without having to worry about testing it each time because we've changed this bit or moved that bit. We just know that we've got the one device, it's on, and no matter what's going on with the rest of the circuit, the microcontroller is going to work, the LoRa bit's going to work, and we're happy. So a lot of the applications that we've used the MAMWLE device in are quite processing intensive. So you can see we mentioned there that we tend to replace relay or programmable logic controller systems. They're systems where previously we've had to buy maybe a £500 controller because we need the processing power behind it to run the application. We're not just talking about one relay being sensed and that being transmitted over LoRa. We're talking about information from pumps coming in, air handling units, loads of big pieces of equipment where we're actually controlling them in real time with the microcontroller, but then also passing the information that's relevant up via LoRa. And it's really nice having that sort of comboed system all in the one board. So if we have a look at some specific ones now, you'll see we've got a few sort of bits struck out with black boxes. Like I was saying, we sold some of these to companies who specifically want it as their product. So I can't show you everything, but we'll try and show you as much as we can. This is a pump controller. So if you imagine maybe a block of apartments, big buildings, we've got a block of pumps at the bottom that are pumping water up through the system. Now, previously, this is exactly what I was just saying. There used to be a controller in there or loads of relays and timers, which would be controlling the pumps, but you didn't know what was going on. Once the lid of the control panel was shut, that was it. You just had to leave it running and hope that it was still getting it right. What we've ended up doing now is we've got this main board that you can see here in the bottom right. This is now the controller for all those pumps. So we can still control which pump is on, how fast it's running, and what's actually occurring at any time. And on top of that, what the system couldn't even do before was we can now transmit that via LoRa. So the client and also the maintenance company, they can see that the pumps are still running. They can see if one's in fault, which one, how fast are they running, what's going on. And it's really good being able to see all that remotely. So if we go here, so this is the online dashboard. So you can see here, we've got faults, enables, runs, and what state the controls are in. All of that is now readily available just on a on a website. So the client, without even if they really didn't fancy walking down into the basement, they can see it on their phone. Or more usefully for us, the service engineers don't have to drive all the way to the site, because these pump controllers are spread out every which way in different construction sites, buildings, etc. We don't have to go there now and check every single one to see what's going on. We've got it all online, and that is just so helpful. And like I mentioned in the last slide, this was our first device using the MAMWLE system on chip, and it's really this was the first one we realized actually we can do so much with this. This is a similar kind of thing. So some buildings you might not have room directly underneath, or even if there's not room for a load of pumps to pump the water up, you might need more storage. So this is an extended version of what we just saw in the last picture, where as well as controlling the pumps, we're now looking at controlling the entire system. So we've got a box underground, and we've got the tanks, the pumps, heating, lighting, the list goes on. All these things can all be controlled from our one device, and it very much in the same way that the MAMWLE reduces the bill of materials. This is reducing our bill of materials again from having to buy relays, programmable logic controllers, just loads and loads of bits of control. We've got it all centered on the one device, and we can see it all remotely. And it's just a real benefit, again, to us and to the client. So you can see a bit of the design itself here as well in the bottom right, where we've got some of our PCB layout. The amount of I/O that we can get off the one device is what lets us do a lot of this, because we are controlling a lot of different things. We need a lot of inputs and outputs. And again, it's nice having one microcontroller that can do all of that without having to worry about extensions to the GPIO or more communications. It's nice and contained. So a non-pump related example. This one's for an air handling unit, and you'll see at the minute the designs are pretty similar, because they're all intended for building management style sort of systems in control panels. So we're looking at a similar idea of the microcontroller then interfacing with a load of different equipment. So here it's monitoring fans, filters, all the controls on the front panel of let's say speeds and which fans are on, which fans are off. The best bit about this project for us was that the previous system, before we replaced it, so we're talking again a control panel of relays, timers, that used to just be a dial for speed and no real smart control of that. Whereas now, A, we've reduced it all down to one board. B, we've now got more advanced functions in there. We can monitor the health of the filters. We can put safety features in that monitor, the fans can't be on if the service door is open or if the filter's been removed. We're adding features as we go. We're not just replacing the old system and adding a bit of LoRa. It really does upgrade what each system can do. With that in mind, then, there's some systems that we can't completely rip out. There's building sites, there's projects where it's not feasible to tear a whole system out and replace it with our own board. So this device here is what we call a retrofit board, because we can look at the current system. So again, it might be pumps, fans, etc. We just want to take a couple of inputs and a couple of outputs from that and see what's going on. And this board is designed to take inputs in and pass them back out, so we can piggyback onto a system without interrupting it. Whatever controls are currently in place can continue working as if nothing has changed. But from a LoRa point of view, we can now see everything passing backwards and forwards. We get that same interface like I showed you on the dashboard. We can now see all the information passing along the system. So even if you can't completely replace everything, you can still get the benefit of adding LoRa to the system and getting remote monitoring. This is our latest device, which is the most interesting for us because it does a lot of different things. It's got a lot of new features, and it's going to be most interesting from a microcontroller point of view because this is our first power constrained device. It's designed to run on a battery. So we're starting to look more at what power consumption each part actually uses. And you'll see from that picture in the top right, there's still quite a lot going on. And even though there's a lot of components there, what's sort of key to managing the power is the ability to toggle bits off and on and off and on, and you get control over how much power the device is using then. So in particular, this is supposed to go on mining vehicles. Imagine if you're attached to some huge digger or truck or something, power is not going to be an issue. But because it was designed for the mining sector in general, it's a device that could be taken off of the mining vehicle, off of its permanent supply, and can then be fitted on a battery down a mine. And we can turn off the unimportant bits. So let's say the J1939 interface that was talking to the vehicle, we can switch that off and not use that anymore. And we've turned the power consumption down. And then we look at some of the inputs and outputs that we're not using. We switch them off, and you bring the power down and down until you've got a nice contained sensor that you can then put down the mine for things like air quality, temperature, humidity, whatever sensor you want to plug into it, really. It's all about the sort of modular part of it and how you can configure what's going on. And again, it's all key to having this microcontroller that we can have so much control over. If we're talking about the control panels in the old PLCs, you don't have the granularity of control. You can't see inside and see exactly what's going on. Whereas here, we've got full control over the system, and we know it's going to work. And that's really, really good. Yeah, the last point about this as well is sort of surprisingly to us, to be honest, LoRa worked very well underground. You can see the picture in the bottom right where we did some testing down South Crofty Mine in Cornwall. And we weren't really sure, to be honest, because it's solid rock either side, essentially. It's really hard to get anything through that. But we got some really good distance out of pretty standard sensors and antennas. We're not talking huge antennas, specialist equipment, just standard stuff. And getting communication all the way down the tunnels in the mine, sort of bouncing around the tunnel. So that was a really good point for us to have proven that the technology does still work down there, and it's still really useful, because there's absolutely no chance of getting cellular signal down there. It's really an advantage to LoRa to still be able to work in that environment. So that was a really good test. We're glad we looked into that. So yeah, that was a bit of a whistle-stop tour of all the things we do. What I hope the takeaway is really is that there's such a variety of things. It's not just the applications I've shown here. It's not, oh, here's 5 things you can do. Here's all the possibilities of working with LoRa, working with the MAMWLE, and from a personal point of view, what we can design at VER FACIL. We're really excited to see all the different applications we're going to come up with this, because what you've just seen there was about a year's worth of development. So in 1 year, we're really happy with the amount of things that you can do. And so let's say 2 years, 5 years, we're really excited to see what comes next, as I'm sure the people at Move-X are as well. So thank you very much. And any questions, let us know. I'll pass it back to you, Elena.
Okay, just 1 second. Ho condiviso quella giusta. So, okay. Thank you so much, Alex, for sharing your experience with our MAMWLE. It's always interesting to see how the LoRaWAN module, our LoRaWAN module, stay in action, let's say. So, if you have any question, this is the right moment to type them in the Q&A box. I just want to say a few words before to leave time to the question. So, if you have any question about the product, or you are considering a LoRaWAN radio module for your embedded system design, you can just email me. This is my email address, ilenia.carola@movex.it. I'm the business development manager here at Move-X. Also, some other information, you can find our website at movex.it. Also, you can type any question you may have at info@movex.it. We have a team of engineers that will be able to answer to all your questions. And also a really useful link is the GitHub from Move-X. We have a lot of documentation that will guide you through example and real life application of our module. Also, you can find us on Instagram, LinkedIn, and YouTube at these links. Don't forget to follow us on the social media to stay updated on all our posts and offers, and also the new product release. Over the next few days, we will share the webinar recording. Here we go. Here we are at the Q&A section. Let's see 1 second if you have something. Okay, not for the moment. If you have any, you can type it now, or you can just type it at info@movex.it, and we will be happy to reply you. So, no question for the moment. Thank you so much for joining us today, and thank you again, Alex, for sharing your experience. So thank you so much, and see you next webinar. Bye.